Welcome, I'm Dr. Abu Farah. In this video, I show you how to find velocity and temperature distribution inside a rectangle with a heat source. According to our model, we have a circle. This circle is our heat source. So we have airflow, the airflow inlet this section and out in this section. So we have two boundary condition, the inlet boundary condition and also outlet boundary condition for the outlet section. Also, we have two another boundary condition. That's these two boundary are insulation. Okay, for us start the simulation, let's move on to Fluent. Select Fluent, right click on geometry and select new design model. Click on X, Y plane and also click Z axis. So click on new sketch, sketch 1. Firstly, we create the rectangle. Okay, now we zoom it. Click on dimension, select this line and also select this line. H1 is 5, V2 is 1. Okay, so back to modeling, XY plan and new sketch, sketch 2, sketching and select circle. Okay, so back to dimension, the distance between the center and this line, L3, 2.5, okay, and also the center and this line, L5 is 0.5. Okay, we have domain. This is a rectangle and this is a circle. The circle is heat source. So back to modeling. Here you see that. Now we want to convert this line to surface. So click on concept. Surface is from sketches. Select sketch 1. Click on apply and click on generate. So now we have created the fluid domain. So now we wanted to create the heat source domain. So again, concept, surface from sketches and select sketch 2, click on apply. Because in this section we have two domain, one domain is a fluid and another is solid. So the circle is solid, we change the operation to frozen because we want to simulate the fluid flow with a solid domain. So the circle is solid domain, so we use a different operation. Okay, so we select frozen. Now click on generate. Here you see that we have two different domain because we have a solid and fluid domain together. So select these two domain and from new part because we want to combine these two domain. Okay. So click on generate and close the designer. Okay. Now right click on mesh, click on edit. We have the domain, so we want to create the mesh. Click on generate. Here you see that we have the mesh. So back to mesh. In this case, the element size 0.05 and click on generate again. Okay, now we want to create the boundary layer. So right click and click on insert, inflation, select this boundary, this domain and also this domain. Okay, so now we want to select the boundaries. We want to create the boundary layers in this boundary, and also the interior domain. So click on apply. We want to create 5 layers. Okay. We want to define the first layer thicknesses. Okay, this is 0.001 meters. So now click on generate. You see that we have boundary layer for this boundary and also for this boundary. Finally, for this boundary. For better mesh, we change the mesh from 0.05 to 0.03 and click generate again. Now the mesh is ready, so click on update. Okay, now we define the boundary condition. So select the line and select this boundary, right click create name selection. This is inlet. This boundary is outlet. Okay. Another boundary, we do not need to define them because the Fluent defaultly consider all another boundary condition installations. Now we want to define the heat source. So select this domain. This is heat source or solid domain. So we rename it as solid. This is a fluid domain. So we use fluid. Okay. So here we have solid, fluid, inlet boundary condition, and outlet boundary condition. So click on mesh and update again. Now close the mesh. Now right click on setup, click on edit. We use 5 solar processes. So click on start. We have yesterday's simulation. So the time is yesterday's. Okay. So we also active the gravity. This value is minus 9.8. Okay. So let's mount the models. We active the energy equation because we have temperature distribution. So click on OK. Click on viscous. For turbulent equation, we use epsilon. Okay. Click on OK. Now we go to materials, the solid domain. You see that here we have aluminum. So we want to select the copper. So click on Fluent database, change it to solid, and now we select the copper. Okay, click on copy and close. So here we have two materials. Now let's move on to set zone condition and click on solid, double click on solid. The material of solid is copper. Okay. Also we have heat source, so click on source terms, click on source test, click on edit, 1 as constant. This value is 50,000. The unit is watt per cubic meters. So click on OK, click on apply and close. Okay. We have a fluid domain. So this is the fluid domain and this is a solid domain. Our solid is copper. So now let's move on to boundary condition. Click on inlet boundary condition. The velocity is 1.5 and the temperature is 300 Kelvin. So click on apply. Click on outlet. For the outlet boundary, we have pressure. This value is 0 because it's relative or gauge pressure. So click on apply and close the window. Now let's move on to initialization. Click on initialize. Okay, so now let's move on to run calculation. We use 1000 number of iteration. And now we are ready to calculate or run the model. So click on calculate. Okay, the run has been completed. So now we want to check the temperature distribution and also velocity distribution. So close the Fluent and now right click on result, click on edit. Okay, click on insert, location and click on plane. Okay, so click on apply. Here we have two domains. Okay, click on colors, variable and select temperature. Okay, click on apply. Here we have temperature distribution. This section or this domain we have increased temperature because we have heat source. Now we want to check the velocity distribution. So click on velocity, click on apply. Here you see that this section we have higher velocity compared to other section because the area of phase fluid decreases. Also we want to check the streamline. So click on streamline. Okay. So we select plane 1, click on apply. So Here you see that we have a streamline. We increase the point, click on apply. This is our streamline. Thank you for watching the video. Good luck.